Geeks or Geeks question 10th में longest subarray with majority greater than k. So we are given an array. This is the array suppose, and the value of k is also given. So what do we have to do? We have to find the longest subarray such that the array contains majority element that are greater than k. For example, here 3 and 4 are greater than k. All the rest are less than or equal to k. So the longest subarray we can find with the majority is 2 3 4, or we can find 3 3 1 3 4 1. Why? Because here two elements are greater than k and one element is less than or equal to k, right? So this is the problem. Now let's try to understand. First of all, what are we going to do? We are going to normalize the array. For example, if the value of the current element is less than or equals to k, then we're going to update it, we're going to replace it with -1, otherwise we are going to replace it with 1. Now after doing this question becomes the exact same replica of the longest subarray with some k, with the positive and negative value, right? And we're going to implement the exact same solution used in this question. So what is this question about? If you haven't done this question, let me explain you. For example, we had to find the longest subarray with positive and negative values, right? So suppose here we are actually maintaining a prefix sum. So like for example, if the value of at a moment, if the value of the prefix sum is 20, suppose, right? And we stored this 20 variable in the map, like 20 occurred at, let's say, 2 position index, right? And we suppose here the value of k was 10. Now at some position we got our prefix sum as 30. So what do? We find the prefix sum minus the value of this k, that is 10. We find 30 prefix sum minus k in that map. Is it occurring in the map? Yes, it is occurring. It is occurring at position number 2, right? So what does that mean? Suppose array had 5 elements, right? The position 0 1 2 3 4, right? So here it is 5 5 and 10. So here the prefix sum is 20, right, at position 2. Now again 5 and 5. So here also prefix sum is, you can say, 30. So we have to find the 10, the longest subarray with the sum 10. So how can we do that? Here the sum is 30 and we have to subtract k. So we have to find the position of 10, that is 2. So the position of 30, prefix sum 30, minus the position of prefix sum 20. It is, of course, all the elements that lies between these positions have to have their sum as 10, right? So basically that is the approach that we are going to use in this question. So this is the same approach. The only difference is that the value of k, what is the value of k that we are going to take? Here the k was variable, but in our case we need the majority greater element, right? So we only need the difference of one single element in order to get that, right? So we are going to do prefix sum minus 1 because we need only the difference of 1 to get the optimal actual largest subarray. So we are going to consider a prefix array, and we will find the prefix array minus 1. If that occurs already in the map, then we are going to take the difference between the current index and the position that has inserted into the map, and that would update our maximum length. And after that we are going to store, if the prefix sum is occurring for the first time, then only we are going to store, because we have to find the largest subarray. So we have to store the first occurrence so that we can maximize the difference between the positions, between the indexes. Okay, so here I've written all the dry runs, like s is our prefix sum variable and this is the map. This is not the current map, this is basically what has added into the map in this stage. You can actually analyze this. I'm not going to read this line by line, but you'll understand after reading this. I've written all the steps. So this is the linear complexity approach, and we have to normalize the array, apply the largest sum with k. That is exact same question, and the time complexity is of n, space complexity is of n. So let's write the solution. We would need two variables, sum is equals to 0 and max c is equals to be 0. Then we are going to okay, we also need an unordered map here, unordered map, and also it has to be initialized. For 0th position we are going to initialize with -1, the index, right? So for int I is equals to 0, we are going to traverse entire array. Now calculate the sum. If the array of I is greater than k, let's say, so sum plus is equals to 1, otherwise sum minus is equals to 1. Now another thing this is the condition. I'm going to explain it why I'm writing this. If sum is greater than 0, then maximum is equals to max of maximum comma I plus 1. Now why I'm writing this? So let's consider an example like 10, 8, 5 and 9, and suppose the value of k is equals to 7. Now here you can see, here there are 3 majority elements, so the answer is 4, right? So we can, if the value of the prefix sum at any moment is positive, that only means one thing. That means that from the 0th index till the current index, we have found the majority. I mean the subarray. If we start the subarray from the 0th position and go till the current position, then it is a valid subarray. Only then the value of prefix sum would be positive, right? So we can literally here the index would be 3. So that is why I've written I plus 1, that is 4, the length of the array, right? This is what the condition represents. Now let's do the thing that I just explained about the prefix. So suppose in the map we have the prefix, I'm sorry, sum minus 1 value does not equals to map dot end. It means that the map has this value. Then we are going to update the maximum with the difference between these positions. So I minus map of sum minus 1. And if the value is new, if the prefix sum is occurring for the first time, so equals to map dot end, then what are we going to do? Then we are going to update the map. So that would be map of sum is equals to the index and return maximum. So this should work. Wait a second, let me minimize this. Oh yes. So as you can see, it is completely working, and you can also see the attempts. I've been trying to solve this since the morning, but whatever. And regarding the yesterday's question, people were complaining in the comments. Actually, the greedy approach was working till the till the time I made the video, and they added new test cases maybe, or I don't know what happened, but that is no longer happening. I don't think it makes any sense to create a video again, but I'll definitely update the GitHub code. All right. So, and yeah, this code will also be uploaded. Okay. Thank you.